plus, leave a blank. And then the A is going to go down another power. But what's going to happen to the B? It's going to actually do what? Go up a power. Is everyone okay with that? Think about it. If you have x plus y cubed, you get x cubed plus 3x squared y plus 3x y squared, and then you get y cubed on the end. Think about multiplying all that out. And what happens is the power in front of the A keeps going down until it's 0. Eventually the power in front of the A is 0, and the power above the N, the B is N. It becomes A to the 0, B to the N by the time it gets to the end. And it just goes on and on. Plus, dot, dot, dot. And this just keeps going down by 1 until it's 0. And of course the B one keeps going up by 1 until it's whatever the end value is. Okay? And that's how the binomial expansion works. Now, I'm going to show you a formula that will find the numbers in front too. Okay? The number in front is always the n factorial over whatever these coefficients are factorial. Okay? Not these powers, these exponents. I'm tired today, I've said a few things wrong. These exponents become part of your coefficient with factorials. And then this one is n factorial over n minus 2 factorial, 2 factorial. This one's n factorial over n minus 3 factorial, 3 factorial. This one is really n factorial over n factorial 0 factorial. And the thing you got to remember is 0 factorial equals 1, folks. 0 factorial equals 1. Okay? That's one of those little tricks of math. 0 factorial equals 1. But that's a binomial expansion. And that's how you find the coefficients out front and everything. Now, if you want to know, you have a plus b raised to the n, and you just want to know a single term without writing all of that out. Say you just want to know the 10th term or the 11th term. The term, a specific term in a binomial expansion, is equal to the a n minus the term plus 1, and it's b term minus 1. And you already know how to get the coefficient out front. It's n factorial over n minus what term it is plus 1 factorial, and then the term minus 1 factorial. And that's a formula for finding them. Like if you want to know the first term, you put a 1 in there, you put the power in there, you get this first term. You want to know the second term, you put a 2 in there for the t, and it works out to this one. You put a 3 in there, it works out to this one. 4, it works out to that one, and it works out all the way across. Okay? Now, do you really want to have to do all that? Probably never again in your lives. But, here we go. If you look at this right here, we're about to use the binomial expansion on that. That's why we learned binomial expansion, is to prove this one derivative rule. All right. Now, so that I'll have room to write as we do this, we'll put it above it. Limit as delta x approaches 0. The first term is going to be x to the n plus x to the n minus 1 times delta x to the first. Don't worry about getting the part in front yet. Plus, then leave a little blank, x to the n minus 2. Delta x will now be what? Squared. Does everybody realize there's really a delta x to the 0 right there, but we don't need it? Is that all right? leave a blank, x to the n minus 3, delta x to the third. See, I have good students to teach. Y'all will listen and write. I don't have to worry about discipline. Don't have to worry about telling somebody to not get up and move around. Gosh, this makes it easy to teach. I'm bragging about y'all on video there, see. Trying to do something positive. All right, plus, got a blank, x to the n minus 4, delta x to the 4th, plus blank, x to the n minus 5, delta x to the 5th, plus blank, x to the n, I want to put, just put x to the first, and delta x to the n minus 1. All right, because that's going, and then plus x to the 0, delta x to the n. And then between these two, I should have put a bunch of what? Should have put a bunch of dots. Okay? Because I don't know how many terms I need because I don't know how big n is. So I went up to the 5th there, and then delta x is 6th, 7th, 8th, 9th, and then eventually delta x will be raised to the n power. All right? And that's the binomial expansion of all that. And notice what is stuck out on the end after you do the binomial expansion. Minus x to the n. All right, I hadn't put it out there yet, have I? Yeah, see Miss Carson there going, well, I don't see it out there. Minus x to the n. And all of that is over delta x. All right, let's talk about the coefficients. Here the coefficient is going to be 1. Okay, here the coefficient is going to be n factorial over n minus 1 factorial times 1 factorial. Here, I don't care. And you can write that on your test if you are really sharp and you're going to, and you can tell your teacher why you don't care. Who cares? No concern of mine. Why? And then what? What? No work. And then not my problem. Not my problem. Not my problem. Oh, I'm about to go back. Not a high school teacher's pay grade. Okay, now, but anyway, notice when you look at this whole thing, look what the first term is, and look what the very last term is. They subtract out, don't they? Now, when they subtract out, I'm going to go ahead and just erase them, because I'm not in my pay grade. Do you notice something about the delta x's? What will factor out of every one of these? A delta x will factor out all of them, won't it? Which means that you could do it two different ways. You could factor a delta x out to the front and write all that down again, or just simply divide a delta x out of this one. You're going to get n fact. What does the n factorial over n minus 1 factorial equal? Okay, let's talk about how to do that n factorial. N times n minus 1 times n minus 2 times n minus 3 dot 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 over n minus 1, n minus 2, n minus 3 dot dot dot. What do those divide out and leave? They leave just an n. Is everyone all right with that? Okay, because see, n factorial reduces to n times n minus 1 factorial, because you go down by 1, and then those two do what? Divide out and leave n. Happy with that? I taught you that last year. Just making sure. Okay, so we get n x to the n minus 1 plus a bunch of goo that we don't care about with a delta x on the end, plus a bunch more goo that we don't care about with a delta x squared. See, that delta x divided out. See that one divided out, right?
Mm-hmm.
See?
Yep.
That one divides out, but it still leaves some delta x's, right?
Mm-hmm.
Do you notice that all the terms left are going to have a delta x in them? Is everybody okay that everything left is going to have a delta x in it, right? Don't care what the rest of it is, I just know it's going to have a delta x. When I have divided out the delta x's, then I can make delta x equal 0, can't I? What's the only one that doesn't have a delta x in it? Right? So you get n x to the n minus 1 plus a bunch of zeros. And there, folks, is what f prime of x equals. It equals at n x to the n minus 1. F of x equal to x to the n. And you've done the proof. Now, this proof, and really, you don't need to know what the coefficient is, because you know there's going to be a delta x left there. 0 times that's going to be 0. You don't need to know what that one is. They're all going to turn out to be zeros. Yes, sir. Yes, sir. But they're all going to turn out to be zeros anywhere there's a delta x left. Now, somebody says, well, Mr. Evans, I just went here. I went delta x here. And then I lowered that one by 1 power. I lowered that one by 1 power. I lowered that one by a power. Lowered that one by a power. Lowered that one by a power. And all of a sudden, and lowered that one by a power. They all gave me 0, 0, 0, 0, 0, 0. And the only one that doesn't give me 0 is the one where the delta x is divided out. And so that is the proof for your very first rule. Binomial expansion. I really think it'd be fun to write, I don't care, who cares, don't need to know this. Or just put, I don't need to know it, because you really don't, because you're going to end up with 0 times whatever that coefficient is. All right? So you don't have to sit there and work out all those coefficients. You could if you wanted to, you just don't have to. N minus 2 factorial. I mean, you can write them out there, but you don't need them. All right? And that's the proof of the very first rule. Now, let's go ahead and do an easier proof. Since I got y'all in here, my second hour students tell me that we don't do any work in here, we just sit around and play. So while we have a second hour student here listening in, we're going to go ahead and do more work than they did today.
I don't think anybody has told you in our class that we don't do enough work. Is that true?
They say we don't do enough work.
Yeah, fifth hour doesn't do enough work.
Oh.
Yeah. They tell me fifth hour gets off easy every day, or sixth hour gets off easy every day. Well, Here we go.
Now.
Definitely. She always has something to complain about. I forgot this was on video.
And we're showing it tomorrow in that class so that I want to teach this.
You're welcome, Meryl.
Okay, what we're going to do is we're going to prove the derivative formula for sin x. Okay? Which is easier than the one we just proved. So, we got f of x is equal to sin x, and then f of x plus delta x is equal to sine of x plus delta x. Alright? And I'm serious, these are easier to prove than what we just did. This is easier to prove than the quotient rule, the product rule. This is easier because it fits. When you look at it, you're going to know what kind of rules you need to look at. All right, you put it in the formula. Limit as delta x approaches 0 of sine x plus delta x minus sine of x over delta x. All right? Now, just a little review. Remember, the limit as delta x approaches 0 of sine of delta x over delta x is going to equal 1. Is everyone okay with that? All right? Because that's theta, 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 right? That's going to equal 1, just in case we need it later on. Now, let's think about something for just a second. Does anything on this board look like something we talked about last year in trig? Say something.
Yes.
Yes, what?
You distribute the sign?
Can't distribute the sign of it, but on the back of your sheet, you had some rules.
I believe.
And the rule said that if you had the sine of alpha plus beta, it equals the sine of alpha cosine of beta plus the sine of beta cosine of alpha. Anytime you see these signs of a plus b, a minus b, cosine a plus b, a minus b, anytime you see a trig function with an a plus b or an a minus b after it, I gave you some identities to help make life easier. All right? If you do not remember them next year, at least carry your unit circle with you. All right? Final exam day here. Show me your unit circle. Okay, I'll give you an A because you're going off to college. At least you got that with you. All right, now, limit as delta x approaches 0. It's going to be sine x cosine delta x plus sine delta x cosine x, and then minus the sine x out here on the end, all over delta x. Okay, I'm going to pull one of them out by itself. Check that out right there. Look at that. Sine delta x over what? Delta x. Isn't that cool? Yeah, we're going to pull it out all by its little lonesome. Limit as delta x approaches 0 of sine delta x cosine x over delta x plus, and then we're going to put all this other stuff out here. This one and this one are just going to stick out here on the end. We're going to do it separate. You can do limits as long as they're added together, we're doing separate. Sine x cosine delta x. Delta x. minus sine x over delta x. Okay. Folks, that's going to be 1 right there, right? Everybody agree that that's going to be 1 times cosine x? So that part's cosine x. Plus, and since we already know the derivative of sine x is cosine x, we know that this better equal 0, right? Okay? Well, let me see if I can help you out here. Limit as delta x approaches 0, factor out a negative sine x, and you'll get 1 minus cosine delta x over delta x. And I will go ahead and tell you that equals 0. I haven't proven that for y'all in the past. I should have. Maybe y'all have used it in your AP Calculus class. That as the limit as theta approaches 0 of 1 minus cosine theta over theta equals 0. The limit of that is 0. And we usually prove it to you and then tell you to memorize it. That's 0. So you get cosine x plus 0, and so you find out that f prime of x equals cosine x. And that's how all the trig ones are. You have to know how to change this a plus b. The sine of a plus b, the cosine a plus b. And those are the only two that you have to prove this way. After that, tangent can be proved by just using sine x over cosine x. But to prove your sine x and your cosine x, you've got to be able to deal with this x plus delta x. You've got to know that trig identity. All right? And I guess when you go off next year to college and you're in class and he's proving this one, I want you to know how he got from here to here. Because he's not going to tell you use trig identity. He's just going to write it down. She is just going to write it down. She is not going to sit there and spend 5 minutes reviewing trig identities with you and all that. Now, one thing you want to know is she's already taught you in her class enough to know this equals 1 times that cosine x, right? And you've already seen it in here enough. But they'll teach you that before you get here next year. So make sure you recognize that that's 1. They will have already taught you this one equals 0. Those will be 2 limits that you're supposed to have already put in long-term memory. What is the one word that I should just say? Memorized. Long-term memory. But there you go. And there's the derivative of sine x is cosine x. Now, if I were doing this in your class next year, what I would do is I would derive this one on the board,